Well, it is great to be here. Thank you, Julio and Michael and Madam Farley, formerly known as. And so I think we're going to spend most of our time schmoozing. So I'm more tuned up for schmooze than I am for snap, crackle, and pop presentation. But I was asked to give you guys a timeline or a little bit of the broad brushstroke. And I found that hard because I started this stuff in 1983, and there were critical milestones along the way, and then there were, of course, lots of things, take-home lessons upon reflection and whatnot that might or might not be fun to share with you. So I couldn't think how to capture all that in just a couple of minutes. So bear with me. I'll talk fast and be brief because I just want to give you a flavor of what this process was like. As Julio pointed out, drug discovery, the way we tried to do it, seemed that it was inevitably destined to be a long and arduous process. CNS drug discovery hasn't been very successful in the last 10 or 20 years, and consequently that made it even more difficult because the diligence that we would have to go through to even begin to raise the kind of resources that we needed to begin to evaluate these things that we created in clinical trials was really perhaps the ultimate challenge, and perhaps the one that most of you might think the least about. I know I wasn't really thinking about clinical trials and the value added of those and the difficulty of getting resources to do them and the high probability of failure for 20 years. I was more concerned with creating something and evaluating it in preclinical models. One of the bad news parts of being an academic and being trained as a molecular biology type is that you really figure that if it works in a rat, it's going to work in a human, okay? And but nobody else outside in the real world does. No, that's fine, go do it, but someone's got to pay eventually to get what we call across the valley of death, which is the preclin, it rocks, to actually getting it into humans. And the problem with drug discovery, unlike maybe an engineering problem, and I say engineering because I think of gizmos and stuff that you have in hands. I see this works. I can never prove that it worked until the clinical trial data came in. So you're in a catch-22 of I'm not giving you the money until I know it works, but you can't tell me, you can't prove to me that it'll work without the money. And that is a lot more challenging than even you might think of how obvious that challenging that is. That's tough. There's a lot of sociology, a lot of timing, a lot of people, and a lot of sweat that you have to grind through. And at the end of the day, it's probably more about just not giving up and hoping you don't get to zero, hoping you don't end up broke and dead in the water. Because I think if you stay at it long enough and you go through the process enough times, you do get refinement, you do get insight, and you do begin to understand what you need to do, even if you haven't got a proof of concept, but what you need to do to get to that point. In other words, it's like a giant connectome. Sooner or later, the VCs and the big pharma consultants are the same people over and over, and they begin to give you good advice. And eventually, if you can pull it off, all of that comes together and you finally get some startup money, and then you're on your way. So that's kind of the broad picture of things. And I thought, like I said, just to kind of be more personal on the program, this is a nice slide. The Falk Center is what we created at Northwestern with the idea that we could put something here in the university and dodge a lot of the bullets that would kill us from the get-go, namely the big resources that we needed. We had the credentials to be acceptable to the university and to be able to find ourselves able to be here. As Julio points out, there's a double edge to that story. It was nice to be under the radar and left alone, because if we had to pass muster, pass tenure tracking, I don't know that we would have been able to do that either. So we had a nice place, and we had wonderful students and faculty collaborations, and we could kind of incubate for 7 or 8 years nickel and diming our way along. And that's not as trivial as it sounds. I mean, you think of the overhead to build a building and do this kind of research and put a staff together and buy the equipment. That's really, really hard. Academically, it was a little bit easier, and the engineering school is great. I think it's the best place because the people are more entrepreneurially minded. The whole environment was supportive, and exemplified by Julio again. He was okay. It was like, yeah, leave him alone for a while, whatever. It's not going to hurt us. And I think that was kind of the spirit all the way through. We always had good students. It wasn't like we were invisible, but you know, we were kind of okay to make sure we didn't screw up, and on the other hand, to kind of do our own thing. And engineers are fun because you make stuff. And unlike, you know, neuroscientists or neurobiologists were great, but engineers are fun. So undergraduates and graduate students and faculty have always been fun to work with, and it's been a great place. But the key to Falk was, as I said, to create something academically robust, great university, great department, and fulfill the robust side, prove our mettle, that we could publish peer-reviewed papers, that we could get NIH grants, that we could train students, because that credibility, tremendous resonance to build the biotech piece. And Norex is the name of the company that we created, and again, it was a little bit of an anomaly because it had always been my vision that the Falk Center, if it was successful, would create something that had therapeutic value, product potential, and that we would eventually have to try to bridge by creating our own biotech company and then hopefully integrate the whole thing under the umbrella of Northwestern without a lot of conflict, without a lot of I think the key word is we distributed the risk as much as we could. So today it's really a wonderful marriage where everything works together, and it really does. My goodness! So we get to have a biotech company within the university. We get to keep our institute so that we can now pull resources in from the private sector to drive our R&D, and we haven't lost the non-for-profit, and we haven't lost the ability to work with students and Northwestern profits as well. So as long as we're successful, it really is a win-win-win. And that was worth it, the 10 years darkness at the edge of town. I mean, we pulled that off. That was good. So I'm going to whip through some stuff to get you from beginning to end point very quickly. And I want to start off in 1983. I just have to pause for a minute. Think how damn old I am. Okay. You notice that's all I put up there, just 1983. That was enough. Gee. Well, in 1983, I had gone through a cycle of graduate school and postdocing, and I was a staff fellow at NIH. And I had the great fortune to work with the fellow who actually deciphered the genetic code. His name is Marshall Nierenberg. You always think of Watson and Crick, who did the structure. But Marshall was the one who deciphered the code and wanted to do molecular neurobiology. And as I said, I was very fortunate to be offered a position in his group. And I mention him because eventually, through that cycle of training, I spent some time on my own thinking about what I was going to do with my life and having this window of opportunity, several years without having to worry about grants or teaching or simply nothing to lose is a good way to put it. Just simply, it was like being in a candy store. Nothing but goodies, you know. Everything was free. It was cutting edge. Everybody who was anybody that I thought was important certainly was coming through our lab because of Nierenberg's credentials. And so I moved to NIMH and worked with another Nobel laureate, Julie Axelrod. And those people were so influential because if nothing else, they got me thinking about the big picture, the long ball, if you will. I was with an entrepreneur in Boston. And he said, "So, how do you like Cambridge? It really rocks, doesn't it?" And this is recent, you know, and it's, yeah, because all these big farmers are coming in with institutes and whatnot. I said, you know, he said, the difference between Cambridge today and a other university town isn't that there's so many smart people, it's that the density of people is high and the resource density is high. So you can ask the bigger questions because you have more stuff to work with. And I think that was, in our own way, one of the beauties of being here at the right time in the right place. We had the density of resources that we needed, even if it was narrow band relative to some other place. So if you're on task, the resources are great. And the point of this is to segue into what I was thinking of in 1983 and what launched this whole damn thing. So I always thought the coolest paper that was ever published as far as the first two sentences, the first sentence. You guys read literature, you know, one of my favorite literary sentences that begins the book is, A Tale of Two Cities, it was the best of times. It was anyway, or Call Me Ishmael. I mean, those are great sentences to start books with. So anyway, this to me, with my background, was like the definitive 2 sentences of all time. I mean, to have something so important that you can actually say, this structure has novel features which are of considerable interest is way cool. I mean, you may not be into this, okay, you may not be nuts like me, but I would never been able to say that and have anybody say, yeah, really? Who cares? Okay, this was the structure of DNA, and it was Watson and Crick's paper, and I thought, wow. And again, you can see from where I was coming from, that was the point. This was kind of the benchmark. But by 1983, this became the great sentence of all time for me, the sentence that launched the whole program. John O'Keefe and Lynn Nadell, senior scientists, published a book called The Hippocampus as a Cognitive Map. And this is the first sentence of their book, which I still to this day think is neat. This book is concerned with 3 topics at first glance do not appear to be related. A part of the brain known as the hippocampus, the psychological representation of space, being a 60s person, anyway, okay, and context-dependent memory. So I'm sitting there going, wow, you know, this is a synthesis, an integration, a whole bigger than the sum of the parts. This is kind of what I ought to try to do. As I said, might as well go for the long ball. I had the environment and really was young and enthusiastic, and this was a chance to dig in and think about a big problem and see how far we could go. So the difference is, as time evolved, we really did stay in hippocampus. We really did look not at space but at affect and emotions and feelings. We look at the emotional substrates of learning and memory, and of course that's related to context-dependent memory as well. So in a sense, I just sort of changed the shape and then had 4 years at NIH to play, and then at each step along the way, wherever there was a critical juncture where we had to make a leap of faith or invent something, we were lucky enough to be able to pull it off, which led all the way to today. So very briefly, this was the first paper that we published way back when. I won't go into the details, but to say from the inception of the idea until 1986 and 1987, so 4 years later, we were actually able to do what I had hoped to do. We actually made a family of molecules or tools called monoclonal antibodies, and I used those to try to perturb function, hippocampus function, to see if I could come up with an antibody that would have an impact on learning and memory processes. And if it did, I had hoped that I could then use that antibody to sort of dissect the molecular mechanisms underlying it. Key point here that I think it'll come up at the end is, instead of thinking about a mechanism and dissecting it and then understanding the mechanism, start thinking about how to make molecules that might be relevant to perturbing the mechanism if the mechanism is relative to disease and therapeutics. I took an opposite approach. I said, let's make some tools that are readily convertible into potential drugs, and let's perturb function first. Let's make sure they work first, and then work our way back to how they work. So we had a platform for screening for function, and we had a toolkit that we could convert into molecules that might have therapeutic potential. That was a neater approach, and it also got me more or less kicked out of NIH, because NIH's attitude was, no, you need to do mechanism. You'll never figure this stuff out. This is crazy. And you know, seriously, this is like, what are you, nuts? And okay, yeah, so all right, fine. So anyway, never mind, nothing to lose and nowhere to go in all day to get there. And so we ground it out, and that's why this is a neat paper to me, because in '86 we showed that we could make the antibodies and actually do what we wanted them to do. And in '87 we started to find that these antibodies, some of them, could actually have an impact on cognitive processes. So 4 years later, or 3 years later really, we started to see some success. Notice we've jumped all the way to 1991. So from, like 1986 to 1991 was another 4 or 5 years of hard work. But again, we finally made the leap. This paper, the title is fancy, but the paper really shows you that one of these monoclonal antibodies, actually we did figure out how it worked mechanistically, and we found out that it still had a big impact on mechanisms or processes associated with learning and memory. So from '83, pie in the sky, By 1991, and with the help of wonderful collaborators, kind of a Tom Sawyer you need to be to do this, you know. You kind of got to convince people to paint the fence with you. We were able to show, yeah, we could do it. We made this toolbox. It did fulfill our wildest expectations in terms of perturbing a receptor complex that was very important in learning and memory processes, and really doing it in an efficient way without being particularly toxic. So that's 1991. Now, what I mentioned was a receptor complex associated with learning and memory, NMDA receptors. This is a nice little slide that I won't go into, other than to point out that NMDA receptors play a pivotal role in learning and memory processes, which is our goal. But we started thinking about therapeutics because look at all the different neuropsychiatric disorders that NMDA receptors play a role in. So remember, I mentioned the idea of function and the idea of toolkits that you could flip into making molecules. It's like a transformer, and you know, hopefully you have something that might be druggable. So that's where we started to think about therapeutics. And by 2008, now that's a big jump. That's, what is that, 9 years? Is that about right? So 9 years later, I'm just going to summarize this because you can see from 2005, 2008, and thereabouts. 9 years later, what we were able to do is convert the antibody into small molecules, which had not been done before, but it seemed rational. And those small molecules took a long time to screen because now we're thinking about druggability. We're thinking an antibody isn't going to be a drug, but an antibody, if we could recapitulate the function of the antibody by chopping it up into small pieces and finding the active part, maybe that would be druggable. And if not, we might be able to make something like it, mimic it, you know, in a chemistry sense, and that mimic might be druggable. So that's why 9 years later. We certainly had a lot of data and direction, but we shifted the thrust now to really going after therapeutics. So the papers show you, you know, glixins. These are the small peptides that are derived from the monoclonal. These guys showed that indeed these small molecules derived from the antibody still modulate learning and memory processes. And then this was our first therapeutic paper, if you will. It's just a little short paper showing, my gosh, Glix13 shows neuropathic pain inhibition. So something of relevance, something meaningful. Finally, we had a model system in which we could actually reverse something pretty nasty. Neuropathic pain, you guys are all probably too young for it, but neuropathic pain, diabetic retinopathies, all sorts of things are neuropathic. And neuropathic means, of course, it's not peripheral where you pinch and it hurts. It's a CNS-mediated pain. Something like a phantom leg syndrome is a good example. You get your leg cut off and it still hurts 5 years later. But so these are CNS processes, and there's really not been much in therapeutics. So this was our first thought in terms of a program aimed at a therapeutic. So that was cool. So that's about 2005 to 2008. Now we switch gears entirely. About 2011, as you can see, we have this little press release that I wanted to show you was another critical transition point. So we're far enough along to have proof of concept in preclinical models and an awful lot of background in studying the mechanism and making molecules. But it was really in 2011 when we were able to raise the first financing. So from 2008 to 2011, I mostly spent on the road presenting the story with my team to at least 100 or more venture capitalists, big pharma type people. And that was hard. I don't know how far along many of you are. I thought thesis defenses in graduate school and sometimes presentations like this would make me throw up, okay? But when you go week after week after week on your own dime and end up in somebody's office on the 40th floor of some building in some big city with, you know, 10 or 15 people that are presumably the experts in the world in my space and are there to find out what's wrong with what I do so they don't have to give me any money, that was quite an education. So that 3 years was not a joke. It was not a joke at all. It didn't make me nasty or anything. It just was very sobering. It was very educational. And fortunately, again, this is partly for being at Northwestern and hanging in there. People like Bill Gantz, who you wouldn't know, but Bill is maybe the rainmaker in sort of investment, startup biotech. He was the former president of Baxter. He joined us and was a transforming event in helping us raise this money. He added credibility, and this is showing that we had already finished a phase 1 and we're now on our way on our way to a phase 2, which meant does it work in these various scenarios. Notice there's no science here anymore. The transition was not showing anybody any more data than I've already showed you. It was getting people that are credible in the industry to buy in. So there's your secret. You need to find a business team. You need to find a CEO or somebody that's got enough credentials to buy in to then communicate the message, because they no longer believe me. They think, well, you're the inventor, rocket scientist, whack job. So of course, you know. And so you very quickly are not out of it, but you really figure out very quickly that it's no longer about you and your publication in Nature. It's quite not about that at all anymore. But it doesn't hurt to have that to get these guys to participate. So anyway, again, only partly due to me, mostly due to all this environment. So that was big, and now I bumped us up all the way to the present, which is, this is a paper that's in press, and the purpose of this is just to remind us that from 2011 to today, 18 million led to another $35 million raise, and both of those monies are all gone, because to do the phase 1, the phase 2A, and the phase 2B, to get proof of concept that it works and that it's safe, costs that much money. Profound amount of money to me. I was running a nice laboratory with a small staff and a group of students for maybe $1/2 to $750,000 a year every year, and that was hard to raise that money, but that wasn't bad. And all of a sudden, kaboom! You're looking at 50 million bucks, gone, and whoa! So anyway, this is a summary of where we are to date. You might be interested, I thought, so to tell you what's going on with GLIX. So what we found in our clinical trials is really neat. The most important thing is, unlike other drugs in CNS that are we switched from pain to depression, and I won't go into that, but just depression, schizophrenia tend to be very relevant in our learning and memory space. So we have a nice mechanism and a nice foundation and a lot of applicability in these spaces, which really have huge unmet needs and are huge markets. As Julio said, gee whiz, depression alone is a multi-billion-dollar a year market with something that works a little bit, you know. So the first thing we found out is what we had hoped is we didn't really see anything in the way of tox. That was probably, I almost feel like you can have a drug that doesn't work, but if it's safe, you know, you'll still make a bunch of money. Because I swear, everything seems to have a narrow therapeutic index and usually is some kind of toxicology associated, especially in this space. Remember, we're a first-in-class novel mechanism, which makes it even that much harder. Drugs like ours or wannabes have all shown fairly significant side effects. The closest we have to something like ours is ketamine. Ketamine is an anesthetic. I usually use it to knock out, you know, put rats and mice and cats and dogs down. If you give it to patients, it has a very rapid antidepressant-like effect, and it persists for a week or so from a single injection, but it has the most robust dissociative side effects you can imagine. It's called Special K on the street. It's a substance of abuse. So if you do ketamine, you are really tripping out, and then maybe afterward you'll see some antidepressant effects. If you do it over and over again, rots your brains out. So that's what we're competing against. Wow. So nice to see something that didn't rot your brain out, or that it wasn't going to cause substance abuse problems in your kids. And we also found this, which is unusual. Any of you, this is high-end academia, right? So 30% of you are probably on antidepressants, right? No, hope not. I'm not. I'm on mood modifiers because I'm manic. No, I'm okay. Not really. I'm just old. And so this is very important. Rapid, robust, and long-lasting. Why? Because everything that's out there, and that's what I was teasing, are SSRI type drugs, serotonin reuptake inhibitors, so Cymbalta, Xanax, Prozac, you name it, that have made megabucks and work a little bit for some people, take something in the order of anywhere from 2 to 4 to 6 weeks before they start to kick in. So if you are one of those persons that needs an antidepressant or an anxiolytic, think about what a drag it is to hang around for a month, wonder if it's working or not working, and if it doesn't, switch to another one. What we need desperately in these kinds of spaces is something that works within a few hours or a day. and to differentiate those that are going to be responders from non-responders so we can move on to other therapeutics. So the non-toxic side effects and the rapid onset and long-lasting effects made it a very attractive program, and that's why we were able to get the Series B financing and get through the Phase 2B, because these properties popped up and hold up very nicely. And again, it hits 50 to 60% at least of the people that have already failed all other antidepressants. So it's not like something you come in from scratch if things aren't working for you. This hits a population that really is in high need, because you go from one to another to another to another, and if you're not careful, eventually you end up getting electroconvulsive therapy because that's all that's left. So being able to target a population with a novel mechanism, first-in-class drug that's safe and robust and rapid makes it a sweet spot, keeps us in the game. There's a lot of interest. And so I will put one more slide up just to be a wise guy before we segue and kind of wrap this up, not by talking about the science and technology, but kind of a little bit of a recap of what I learned along the way that I think but really is important. And I wanted to share that with you, even if maybe you've heard this before, because it's interesting. It really is for you youngsters to think about, because I think entrepreneurialism is way cool. But as I told you, I had an opportunity as a young man to be in an environment where it was okay to ask a big question and be an idiot, okay? And no one is going to give me a job because I asked the question, so you have to figure your own way. And that's when you kind of figure you're an entrepreneur. You start selling your firstborn kid and you go, hey, I'm an entrepreneur. I'll do anything to keep my project going. But it's nice to understand what we're talking about here. These questions that I was asking were not ludicrous. They were fun because I was able to at least address them and think about them and set up a program of milestones, and if I hit them I get to go on, and if I don't I have to figure out what the hell am I going to do. So it's really that kind of a mindset. The long ball, the entrepreneurial thing, keep that in the back of your mind. It's something that if you have a passion for something, you need to do it. If you don't, be careful, because it's so prone to failure. I don't know what the baseball average of a typical guy that hits a lot of home runs is, but if you're going to go for the long ball, you're going to strike out a lot, you're going to hit in the head a lot, and you're going to walk a lot. But the key is to keep getting up to the plate. So somehow, some way, you have to balance the high probability and repeated failure against, you still have to find a way to keep swinging. Otherwise, then the game is really over. So that's what I meant by understand what that means. And this is my favorite: fail early, fail often. It's better to be young than old. Because failure when you're young is easy. You just do something else, or you're tough and you're broke and you don't have any resources anyway. Later on, you get pretty much ensconced in a lifestyle and have a lot of baggage, like family, kids in school, and it becomes a little difficult to trade the family for your wild idea. So fail early is also, you might as well plow in and learn. And it's a cyclic process. I said it was 3 years of going to VCs and pharmas. It was nice because it wasn't adversarial, like, get out of here, you're stupid. It was more or less, no, we're not ready for you, here's what we think is wrong. And if you can figure out how to solve the problems, you get to come back and see them again. So eventually that cycling process refined our story. It was super helpful in directing me to think more about how to get a therapeutic going, and eventually we were okay. Again, why the Falk Center model was such a powerful model for me, because it kept me off the streets. It kept us functional when we might not have been able to otherwise. And I always felt that this is probably even more important than 1 and 2. Make sure you work with people that are better than you. Look around your team, look around at your staff, look around at your agenda, and your first index that you're on the right pathway is if the people that you can bring in know more or do better than you do. That has been a godsend, to be able to not freak out when people come in that are so awesome. I could go through a whole list of people that have really made Norex what it is, and this has been a pivot to really reinforce getting the best people and keeping them in the game. This is sad but true. It's really not about you, it's about your CEO. It's, at the end of the day, it's the Bill Gantzes and Norbert Riedels and whatnot that really move the program from a good idea or a big research program to actually a company. And I used to be cynical about that, but I realized that when people are involved in dealing with a lot of resources, a lot of money, they like to be with people that understand that and know how to do that as well. And no matter how smart I might be or not, or what I might have invented or not, there's a big disconnect because there's a whole different world of business and business development, and it's a fairly small community. The caveat with this is, yes, as you as an entrepreneur don't get founderitis. In other words, don't try to hold on to your company. Don't try to hold all the stock. Give it to the better people, identify them, reinforce them, let them build. The downside is the old Groucho Marxism, which is anybody that would invite me to join their country club, I wouldn't want to join. Okay, it's hard to find CEOs when you're starting up. That's what the fail early, fail often. It's hard to find people that have the credentials and experience to drive you through all of these dark times. And I went through multiple little startups and multiple CEOs along the way, trying to bootstrap to where we finally got the people that we needed and made the spark go. And at that point, usually the science is taken for granted eventually, and the business model becomes the more important model. How to really market it and develop it. It's really key. If you're going to do this, if you want to just be an academic, and not just an academic, but an innovator in an academic setting, then you don't really need that. But if you want to do something like develop drugs or any kind of biotech-driven enterprise, keep your eyes on the business side of it. You don't have to do it, just have to find the right people. And again, what a great university for that with Kellogg and whatnot. So keep that in mind. And then, as I mentioned, a more advanced concept. We went after making tools and probing for function, as opposed to the standard model, which would be, I'm an expert in N-methyl D-aspartate receptors, I know more than you do, therefore maybe I can figure out with another academic how to design a drug. Okay, that was fine, but we didn't do it that way. We said, let's make tools that might have like a Rector set or Tinker Toys, and let's make sure that they work first, and then we'll circle back and make sure we know how they work, and that will help us. And then, as I said, we had, the approach gave us a platform to quickly create drug candidates and an approach to identify them. So I'm here today in part because I've learned all those lessons and survived it. I've been blessed by having people better than me all the time around me. And the original idea had enough time to incubate before I went broke so that we got some results that were good enough to get people interested enough to keep us going. So that's kind of my story. I hope I didn't talk too long. I have no idea how long I talked, but it's probably too long. But anyway, so that's the background. That's the lay of the land. Right. Yeah.